Today's lesson deals with finding the distance between a point and a line. That's probably the biggest, the most challenging problem on the test. It's the one I see most frequently missed, so pay attention so you can get this concept. First step, it's good to see what does this look like. So I'm going to draw a picture of it instead of writing a definition. So a distance from a point to a line. If you have a graph, and then you have a point graphed on it, and then a line on it, how would you determine the distance? Well, you first need to visualize the distance. Some people say, oh, I'll just kind of count over this way and there's the distance. That'd be wrong. That would be a bad way to look at distance. You want to pick the shortest distance possible. And the shortest distance possible would not be just straight over. Instead, you would see it as this. Here's the point, here's the line. You need to see it as this distance. What do you notice about the blue line compared? Yeah, they're perpendicular. The key things, they are perpendicular. You want the perpendicular distance. Really, all I need to do is figure out the length of this piece. Can I count a diagonal line? Yes or no? No, I can't count a diagonal line. So you either need to do the distance formula or Pythagorean theorem. These are your two options. You can't count whenever your line is diagonal. The only time you could count is if you had horizontal or vertical lines. That's the key concept you need to get from distance from a point to a line. So the next thing we need to do is talk about these theorems. They deal with perpendicular lines and special little tricks. So this first one says, if two lines intersect to form a linear pair of congruent angles, there's our congruent angles. They're a linear pair because they make a straight line. Then the lines are perpendicular. So once again, what are the perpendicular lines? G and H are perpendicular. So the key thing, if these are a linear pair and they're congruent, they have to be 90s, making those lines perpendicular. The next one says if two lines are perpendicular, they intersect to form 4 right angles. So this means if you're given one as a right angle, then the rest around it are also right angles. Pretty easy concept. These are all right angles. Pretty simple. Kind of applying those theorems, that's what we're going to be doing on example 1. On this one it says, in the diagram at the right, angle 1 is congruent to angle 2. What can you conclude about A and B? Lines A and B. What could you tell me about those? They're perpendicular, plain and simple. Lines A and B are perpendicular. So I would just say A is perpendicular to B. That would be my conclusion. What could you tell me about angles 1 and 2? They're congruent. What else could you tell me about angles 1 and 2? They're a linear pair. This is extra stuff. They're linear pairs. What else could you tell me about 1 and 2? If they're congruent and they're a linear pair, how big are they? They're 180 when you add them. How about separately? 90. So measure of angle 1 is equal to measure of angle 2, and they're both 90 degrees. You could also say angle 1 and angle 2 are supplementary. This stuff on the side is definitely over and above what's going on in that example. On the next page we have Theorem 3.10. It says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. They are complementary. So that word goes here also. What's complementary mean? Add the 90. So write that out to the side. Measure of angle 1 plus measure of angle 2 is 90 degrees. I used to say blank plus blank is 90. That's what we used to write in the past. I'm actually not going to be doing these proofs. I don't like how they do them. I don't like the reasons they give. These are not good reasons in my opinion because Theorem 3.8 may be different from book to book. So I don't really like these. These are not exactly how you'll see them on the test. The only thing that I want you to get from this proof is this. If it tells you they're complementary, what reason will you probably be using? Definition of this word, definition of complementary angles. You will be using that definition. Look for the keywords. That's the concept I want you to get. If you don't look for the keywords, you're missing easy points. Try this checkpoint. Try checkpoint number 1. I think it's pretty simple. It just says, what do you know about the sum of 3 and 4? It's pretty simple. All right, so what do we say on checkpoint number 1? What could you tell me about the sum of the measures of angles 3 and 4? They're supplementary. So angle 3 and angle 4 are supplementary. Why? Because they are a linear pair. That's a pretty quick, simple answer. Looking at this one, without even reading a whole lot, what do you see are the key words on number 2? What are the key words? Right angles. So this means we might be using definition of right angles. The other thing that I'll look at, to be able to say they're 90 degrees, they're perpendicular, and changing that to right angles, we're probably going to be using the definition of perpendicular lines. Without even doing a whole lot, I could guess at those. Without even reading the question a whole lot, I could guess at those. We might be using definition of right angles, or we might be using definition of perpendicular lines. I would bet that one's good. That last one that I wrote for the blank number 3 would be good. Here's some more theorems in this section. It says 311 is the perpendicular transversal theorem. If a transversal is perpendicular to one of the parallel lines, then it's perpendicular to the other. Basically, it's saying if it's perpendicular up here, then it's perpendicular down here. That's all it's saying. So all you got to do is realize that one is a perpendicular mark, so the other is also perpendicular. That's assuming you have parallel lines. And yes, we do have parallel lines due to the arrows. All right, this one's a little bit different. It says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. This is just kind of going backwards from this, saying, all right, right now we don't know if they're parallel, but if they're both perpendicular, then they have to be parallel. I can now add the parallel marks, and I can add the parallel symbol. Here's where some people have a little bit of difficulty. We have a lot of lines in this picture, and it says determine which lines, if any, must be parallel in the diagram. Explain your reasoning. Anybody got any guesses on which ones? They all look, it looks like there's a lot of parallel ones, but you got to be able to give reasoning. Anybody got any guesses on which ones are parallel? X and Y are parallel. But why? For what reason? They're perpendicular to the same line. They are both perpendicular to what line? They're both perpendicular to R. All right, there's one of them. So we have R and S are parallel. There's more. y and z. So they're perpendicular to the same line. Which line are they both perpendicular to? Yeah, it doesn't work for y, z. They're not perpendicular to the same line. Y is perpendicular to r, z is perpendicular to s. So no, we can't say y and z are perpendicular. I'm going to write it up here. Y is not perpendicular to z. They're not perpendicular to the same line. Sorry, y is not parallel to z. All right, any other lines? X and z are parallel. That is true. Why? For what reason? They are both perpendicular to what line? They're both perpendicular to line S. Is there any more? I see one more. We already, oh, okay. So, R and S, those are those vertical ones up here. So R and S, they're perpendicular to which line? R is parallel to S because they are both perpendicular to line X. Good. Good job. Try these down here on the checkpoint. I'll give you a little bit of time to try these. So in this picture, it says C is parallel to D and explain. Is C parallel to D? Yes or no? It is a yes. Why? They are both perpendicular to what line? To line A. And that's correct. You can see the perpendicular mark on both of those. Is B, now this is different, is B perpendicular to D? B perpendicular to D, so this is a question mark. We got to figure that out. B perpendicular to D. I've heard no, I've heard yes. I've heard yes. I'm hearing a little more yeses now. So how can you conclude that though? I'm hearing yes. I'd probably say yes too, but why? What's the reason for that? C and D are what? C and D are perpendicular to A. Yeah, getting a little off a little bit. I know you know what you're saying, yeah. What's the other part? And B and C are perpendicular. Yeah, so D is also. I understand, you know what you're saying, not the greatest. Basically because perpendicular here, here, and here, you can conclude the last one. So that's the key concept there. It's kind of tricky, but because we're perpendicular in those 4 spots, then they're all going to be perpendicular. If I didn't have one of these others, it would not be perpendicular. That's what I've learned over time. All right, example 4 is the one that I've noted people miss on the test. It's the majority of you will miss this if you don't get it today. I'd like for those stats to change. I'm not going to convert it to really talking about a real world problem. I want to just look at the pure data, the points. So it gives me a point up here, 2974. So I can put a little dot on that and make it stand out a little bit more. This is 2974. Gives me another point over here and another point over here, and those are noted by R and Q. Now earlier I said you need a point and then a line, and then you need to be perpendicular to it. So which one do I want to call my line in that picture? QR, I'll agree there. So it kind of matches my picture over there. So QR, we'll call that our line. I need my slope for QR. So I got to calculate my slope for this line over here. How do I calculate it? What's my little formula I plug into? y2 minus y1 over x2 minus x1. So what do I plug in? I would do 55 minus 34 over 91 minus 71. So what's 55 minus 34? 21. And 91 minus 71? 21 over 20. That's my slope. But what did I say over here? Do I want the slope or the perpendicular slope? Perpendicular slope. Okay, opposite reciprocal. Oh, good thought right there. So instead of wanting this one, I want the opposite reciprocal. So that is perpendicular to a slope of negative 20 over 21. Truthfully, I don't like these real big numbers. These are way larger than you'll see on the exam. And I'll actually be giving you a graph to make it a little bit easier. Kind of tricky on this. So just be aware of that. So once again, we've done slope, we've done slope. The goal, though, on my graphs will be to actually draw this new slope. So I would actually go down 20 and write 21 in that picture. And I would determine that it actually lands me right here. So what you should see is I need to find this distance right here in green. And I had two methods for finding distance. Who remembers what two methods we wrote earlier? Distance formula or Pythagorean theorem. I like Pythagorean theorem. I'll show you how to do it in a little while, but let's do distance right now. I want to find the distance between these 2 points. So once again, if you don't remember the formula, it is x2 minus x1 squared plus y2 minus y1 squared. That is on the board. I'll give it to you on the test. Not a big deal. I got to substitute my values, though. So here are my 2 points. I got to determine which ones are x1, y1, x2, y2. And I usually go left to right, so here's my x and y. This is my first point. The other one to the right is going to be my second point, so x2, y2. I'm going to plug these in my formula. What's my x2 value? Read. x2 is 71. What's my x1 value? 29. Now my y2 is 34. My y1, 74. So we're going to get some big numbers here. You definitely need your calculator. 71 minus 29. Type that in real quick. So we get 42, and that's going to be squared, plus 34 minus 74 is negative 40. Square that. Now notice, I have the negative inside the parentheses, and then I'm squaring the whole term. Anytime you square a term, it's going to come out to be positive. You got to make sure of that. Type in 42 squared and tell me what that is. 1,746. And type in 40 squared, negative 40 squared. 64. 64, okay? So squaring negative 40. What's that? 1,600. Add those two numbers real quick and tell me what you get. Tell me what you get. 3,364. Square root that amount and tell me the approximate answer. Can you give me a few decimals? Is it 58 exactly? Oh, it's 58 exactly. Doesn't always come out to be that. So 58, this one has units. They're measured in inches. So that's 58 inches. So this one is harder than what's on the test because it's such large numbers and the graph doesn't help you a whole lot. We're going to try one more in the checkpoint though. Try this checkpoint. Remember, find your slopes of your lines first. Then draw the one you're going to find the distance of. All right, here we go. Here's what I'm looking for on this one. On this one, you have to figure out which one do you want to be your line and which one do you want to be your point. Find the distance from a point to a line, or distance between two lines. They've done some of the work. They've done a lot of the work for you. Earlier we said, all right, we're going to pick these two over here, so we're going to keep that the same. Let's find the slope of this line. It goes up 3, right 1. That's quick. I don't need a formula for that when it's graphed. But I want to make sure I'm measuring perpendicular. So what point do you think I should examine? I should look over here at probably that point. And I'm checking to see, is this a perpendicular line, to make sure I'm counting the right ones. So how do I figure out if this is perpendicular? Oh, I need its slope as well. So I can count this one. Going left to right, I go up or down. Down 1, right 3. Down 1, right 3. Are these slopes perpendicular? Definitely, definitely. So since these are perpendicular, and you could just say, I would be okay with this. 1/3 is perpendicular to 3 over 1. Now we can find this distance, and I'll make it red. This is the distance we're going to find. That means these are the points I can use in my distance formula. I'll say x1, y1, x2, y2, and I'll plug in my formula. I remember y2, or sorry, it doesn't matter which one you do first, but let's do x2 minus x1, so it's minus and negative 2, and then y2 minus y1. Then we're going to have to simplify some of this stuff. We know this changed to a plus. 1 plus 2 is 3. So I'm going to be doing 3 squared there. Bring my radical down. 2 minus 3 is what? Negative 1. What's 3 squared? 9. 1 squared is 1. Square root of 10. You can approximate that to be 3.16 is what I saw. So I just had a good question asked. They said, why do we have to make sure they're perpendicular? Well, if you remember my example earlier, I drew a line and a point. And I said, well, can I just say this is my best distance? That's the distance I'm going to calculate to my line? We said, no, that's not a good distance. We want the closest distance. And I drew this. And you all told me, what do you notice about those two things? They are perpendicular. It has to be perpendicular to be the shortest distance.